Hello, my dear student. How are you? Hello, my dear student. How are you? Welcome to Gate Wallah. So, today we are going to discuss casting and welding questions. So, are you people ready? Yes. Let me know that are you people ready? Now, I'm going to start this session. Good morning, Abhijit. Good morning, Devil, Rahul. Good morning to all. Good morning to all. Good morning to all. Let's wait for 2 to 3 minutes. Then I'm going to start this session. My dear student, before starting this session, I have a very good lines for you by Malcolm X. Okay, what Malcolm X said? Malcolm X said that education is what? Education is our passport. Education is our passport to the future, right? Education is our passport to the future. For tomorrow belongs to the people. For tomorrow belongs to the people. For tomorrow, remember, for tomorrow belongs to the people who prepare it today. If you prepare it today, then it become passport for you people to go anywhere in the world, to explore the new thing with your freedom of speech, right? So this is a very beautiful line by Malcolm X. In the morning I read it, so that's why I decided I should share with you, right? So keep hard learning, right? So keep hard learning. During this process I am with you. Okay, so shall we start our session? Are you ready, people? Shall we start? Okay, now let's start with this session with a very new question, as you people are demanding, as you people are saying, sir, please increase the level of question. Okay, so that's why me and my team have decided, okay, to do some work on the questions so that you will get a new questions, right? We have selected some new question from the standard books, right? And we did some changes. So here are the questions. Now let's start. Let's start. Now the question is in front of you. I'm going to give you 2 minutes to solve this question, right? I'm going to give you 2 minutes to solve this question. So please solve this question. Good morning, Karthik. Good morning. Good morning to all. Yes, please solve this question. What the question says? What the question says? A heat source transfers 3000 watt. Okay, please note down the important data. 3000 watt. Okay, 3000 watt. Please note down the given data. Please note down the given data. There is a source which produces what? 3000 watt. Okay, to the surface of metal part, the heat impinges the surface in a circular area with the intensity varying inside the circle. Okay, there is inside the circle, the distribution is as follows: 70% of the power is transferred within the circle of radius 5 mm. There is a 70%. Okay, from this 70% is going to transfer to a circular disc, and let's say this is a heat source. Let's say this is a heat source is placed inside the circle, and the radius is 5 mm, right? The radius is 5 mm. Okay, now, and 90% is transferred within a concentric circle, means there is another circle, my dear. There is another circle. If this is a heat source, this is a circle of radius 5 mm, and there is another circle of radius of what? Of radius of 12 mm. This is a circle of radius 5 mm, right? This is a circle of radius of what? 12 mm. Okay, and 90% is transfer. Okay, where a concentric circle of diameter of what? 12 mm. So what are the power density? You have to tell me the power density in watt per mm square. Sorry, you have to tell me the power density in watt per mm square, right? In watt per mm square, where when the diameter of the inner circle is what? You have to tell me the power intensity in the circle whose diameter is what? 5 mm. Okay, and in the circle whose diameter is what? Sorry, it's a diameter. It's a diameter. Okay, it's a diameter. It's a diameter, my dear. So 12 mm is what? 12 mm is the diameter. 12 mm is what? The diameter. Okay, 12 mm is what? The diameter. So lie around the ring. So can you solve it? Sir, DPP kahan milega production ka? Dear student, I have included the extra question in the class notes. So after, I mean today I have a 16 question, and usually in 2 hours we are going to solve max to max 10 to 11 question. Remaining question you can do yourself. Don't worry, Karthik. Okay, in my notes you will get the extra question, right? In notes, some of the remaining question I am going to give you as a homework. It will work as your it will work as a DPP, right? Now please solve this question without wasting any time. Please solve this question without wasting any time. It's a very good and new question. Now you people say, sir, how that heat source, I mean from where the heat is coming? That heat source of what? Maybe the heat source of acetylene. Suppose that a acetylene flame gas is using in the inner circle, and that acetylene gas flame act as a heat source inside that circle. Inside that circle, 23.88 Karthik says that, sir, power density is what? 23.88. Beta, in which part? For A? Are you talking about for A, Karthik? Are you talking about for A? If you are saying A, then my dear, I'm sorry to say it's a wrong answer. But it's I'm sorry to say it's a wrong answer. Okay, let's wait for the others. No, beta. 23.88 for B. 23.88 for B. 23.88. No, sorry. Again, it's a wrong answer. Karthik, again it's a wrong answer. Again, it's a wrong answer. Right? No, not for a B. For a B, it's not the right one. So, shall I solve this question? I think nobody is able to solve. Nobody has able to solve. Nobody has able to solve this question. Huh? Nobody has able to solve this question. So in the market, this is a new question, huh? 106.952. Yes. Karan Bhadoria. Yes, right one. 106 something is the right one for option A, and 6.4 is the right one for option B. Okay, let me solve this question. Only one student has given the answer. It means it's quite difficult. So let me solve this question. Okay, I'm going to solve this question, my dear student. No need to worry. Okay, no need to worry. I am going to solve this question. I am going to solve this question. See. Yes. See. Okay. See the question. Now, inner circle, first of all, you should find what? First of all, you should find inner circle area. So the solution is inner circle area. Right? Inner circle area is what? Pi by 4, and the diameter is what? 5 mm square. So this is the inner circle, right? This is the inner circle area. So the answer is, shift pi by 4 5 square, right, into 5 square. So it is what? 19.634 mm square. Okay, this is the inner circle. Now power intensity, here power inside the area, power inside the area. What is the power inside area? It is given that 70%, it is given that 70% of that power is distributed, okay, inside the area. So 0.7 into 3,000, it comes 2100 watt. 2100 watt. Now the power density, you have to find the power density, right? You have to find the power density. So my dear, power density is, power density is what? Basically the power, that is 2100 watt divided by what? 19.634 per mm. Basically it is an mm square. So 2100 divided by answer, it comes 106.95 watt per mm square. Now the next question, now the next part, okay, now the next part, my dear student. So the next part is for the outer circle, outer circle whose diameter is what? 12 mm. So the area of the outer circle is what? That is pi by 4 12 square, pi by 4 12 square, right? Pi by 4 12 square. So here shift pi by 4 into 12 square, it comes 113.097 mm square, right? Now see the power density. Now the power outside the circle, power outside, okay, power in 12 mm dia circle, 12 mm dia circle. My dear, in 12 mm dia circle, what he says, 90% is transfer. 90% is transfer within the concentric circle. Okay, 90% means 90%. Okay, 0.9 into 300. Is that right? Is that right, my dear student? Is that right? 0.9 into 0.9 into 300. Is that right or wrong? Is that right or wrong? Just say yes or no. Is that right or wrong? Wrong. Because from 3000, 70% is taken by what? 70% by taken the inner circle. So 70% is what? Is taken by inner circle. That is what? 2100. So minus 2100. This was the power in 12 mm dia circle, right? This was the power in 12 mm dia circle. Is that right? Are you understand this thing? Are you getting this point? So 0.9 into 3000 minus 2100, it is coming 600, my dear student. It is coming 600 watt. 600 watt. So 600 watt. So my dear, the power density is what? Power density is 600 divided by 113.097. It comes out, answer divided by 113.097. It comes out, just check your answer. It is a concentric, na? It is a concentric. It is a concentric. Oh, I did a very mistake. I did this mistake. So just see area, because the area is concentric, na? The area is what? The basically it's a concentric circle. Concentric circle means please see concentric circle means, okay, concentric circle means, see the concept behind that question. See that concept behind that question. Okay, this is what, this is let's say okay, now see. Okay, so I am going to draw a circle again. See, my dear student, there will be a heat source. Okay, so the power, the 90% power is distributing in this area. The 90% power is distributing in this area. So what will be that area? That area is what? Pi by 4 12 square minus what? 5 square, right? Pi by 4. So that area is what? That area is what? So here pi by 4 into 12 square minus 5 square. So it will come 93.462 mm square. Am I right? 93.462 mm square. So this should be the area where 90% of power is distributing in the outer circle, right? So here the area is what? Pi by 4 12 square minus 5 square. It will come 93.462 mm square. Okay, mm square. So here I am going to remove this. So here 600 divided by 93.462. So 600 divided by answer, it is coming 6.419 watt per mm square. Is that answer is clear? Is that explanation is clear? Is that explanation is clear? Yes or no? Is that explanation is clear? Is that explanation is clear? Yes or no? Are you ready for the next question? Are you ready for the next question? My dear student, tell me yes or no. Are you ready? Are you ready for a next new question? So here is the next new question. Please solve this. Please solve this. The power source in a particular welding setup generate how much? 3500 watt. It is recommended, or it's my suggestion, that you should note down. You should note down that given data. You should note down the given data. The power source is generating how much? 3500 watt. That power source, that power may be produced by acetylene welding. That power source may be produced by laser welding. Okay, and by using any welding, you can produce that much power source. Okay, examiner can manipulate in this. Examiner can manipulate this power source. Examiner will say that by using acetylene gas, by using 5 kg acetylene gas, 2 joule, okay, or by using 5 meter cube acetylene gas. Examiner will ask, by using 5 meter cube gas, okay, by using 5 meter cube acetylene gas, a particular power is produced, and for 1 meter cube the power is produced by the acetylene is, let's say what 2 joule per meter cube. Then total power source is 10 joule or 10 joule. So power source could be anything, right? That power source you can produce by any source. Am I clear? Now let's move. That can be transferred to the work surface with a heat transfer factor. With a heat transfer factor is what? 0.7. Transfer to the work surface. The metal to be welded is the low carbon steel whose melting temperature is what? Melting temperature is also given, that is 1760 degree 1760 Kelvin. 1760 Kelvin. Please note down the data. The melting factor in the operation, is what? 0.5. The melting factor in the operation is what? The melting factor in the operation is what? 0.5. The continuous fillet weld is to be made with a cross section area 20 mm square. With a cross section area 20 mm square. Determine the travel speed. Determine the travel speed at which welding operation can be accomplished. Welding operation can be accomplished. Here is a relation that EM equal to KTM square. What is EM? EM is the unit energy for melting, that is in joule per mm cube. EM is what? The unit energy for melting, that is in joule per mm cube, and K is the constant whose value is what? 3.33 into 10 to the power minus 6 joule per mm cube per Kelvin square. Tm is what? The melting point of the metal on an absolute melting temperature. Absolute temperature means absolute melting temperature, that is in Kelvin. So find out the travel speed. Find out the travel speed. Let's see who is going to solve this question. Vishal Dhiman say, sir, it is a 5.93. Vishal Dhiman say it is a 5.93. Anybody else? Anybody else? Sanjay Katyal say, sir, it is 118. Beta, 118.7. It with mm per second. 118.789 mm per second. Okay, I am getting another one. Anybody else? Anybody else? Yes. Rishabh say 5.938. Rishabh says 5.938. Rishabh says 5.938. Shall I solve this question? Shall I solve this question? Shall I solve this question, my dear? Okay. Okay, Karthik Singh says 16.9. My dear, here we get three answer. One is 5.93 mm per second. Another one says, sir, 118.8 something. Okay, mm per second. And the another answer is what? 16.9. Another answer is what? 16.9. Okay, mm per second. All the answer in mm per second. Okay. Now let's see which one is right. Now let's see which one is right. So one answer is, let's say option A, 5.93. Second is what? Option B, that is 118.8 mm per second. Or option C, 16.9. I am neat student, sir, but I like your voice. Thank you. You like my voice? Am I a singer? Am I a singer? Sanjar Bhai Shots. I'm not a singer. You like my voice? Okay. Thank you. It's a nice compliment, huh? You like my voice. It's a nice compliment. It's good that you only like my voice. हाँ संजर, क्यों संजर? बस ये अच्छा है कि तुमको सिर्फ वॉइस ही अच्छा लगता है, बाकी और कुछ है ना भाई? ठीक है ना, समझ गए? चलो, ये अच्छा है कि तुमको वॉइस ही अच्छा लगता है, कुछ और अच्छा लगता तो भाई अपन वो नहीं कर पाते. हाँ, it's good that you like only my voice. Of course, if you like my teaching, then it's also good. But apart from my voice and teaching, if you like something else, then I'm not able to give that thing. Sorry. Okay. Okay. Lots of student has given the answer. Lots of student has given the answer. Let's solve this question. Right? Let's solve this question. Let's solve this question. Let's solve this question. Okay. Here, power source is given na beta. Here, my dear, power source is given. Right? Here, power source is given. That power source is what? P. That is what? 3500 watt. This is a power source. Right? Heat transfer factor is what? the heat transfer factor, oh my dear, the heat transfer factor is what? Heat transfer factor, right? Heat transfer factor is what? 0. How much? 0.7, right? Also here melting temperature, that is Tm, that is 17, how much? Let me see the data. 1760 Kelvin, right? Now the melting factor, there is another data which is a melting factor. Okay, melting factor, I think it will be 0.5. Oh sorry, 0.5, right? Now the area which is going to be weld, now the area, the welded area, right? The welded area is what, my dear? Welded area is 20 mm square, right? 20 mm square. Now here the equation is given. The equation is, what is the equation? That is a EM equal to K Tm square. My dear, here the EM is what? In joule per mm cube. Energy produces in joule per mm cube. So joule per mm cube. Okay, we know the value of K here. We know the value of K. So we can find the value of EM. K is what? K, the value of K is 3.33 10 to the power minus 6. 3.33 into 10 to the power minus 6. Okay, Tm, that is 1760 square. That will be in joule per mm. Okay, joule per mm cube. So what will be the answer? 3.33 into 10 to the power minus 6 into 1760, okay, square. It comes 10 point, EM is coming 10.315 joule per mm cube. Are you getting this thing? Now the energy which is coming from any source is what? Is the basically 10 point, right? 10.315. Now suppose that we know the melting efficiency, because he says a melting efficiency also. So we know that, my dear student, that for melting efficiency, what is the heat which is required? The heat which is required divided by the heat which you are giving as a input. Am I clear? So from the power source 3500 is coming as an input, but only the transfer factor is what? 0.7. So 0.7 times of 3500 heat is coming. Okay, so the heat input is basically, what is the heat input? The heat input is, I think it will be the 0.7 times of what? 3500 watt. Am I clear? Is that clear? So here the required heat is what? The required heat will be, okay, now we have to calculate the required heat. Okay, so here the required heat, now how much area, how much volume you are welding? The cross sectional area of the weld is what? 20 mm square. Let's assume that the welding speed is what? V. So A into V, that much area that much volume I am welding mm cube per second, right? And that much heat is required, for 1 mm cube. So multiply it 10.315, that is in joule per mm cube. So mm cube cancel, joule per second, that is what? So it is coming, area is what? Area is 20 into 10.315 into V. So that is in watt, right? So the melting efficiency is 0.5, that is 0.5 equal to heat required is what? 20 into 10.315 into V, divide by divide by 0.7 times of. Okay, so here 0.7 times 3500. Am I clear? So the answer is 0.5 into 0.7 into 3500, okay, divided by bracket answer into 20. So my dear, yes, you are giving, some of you are giving the right answer, that is 5.937 mm per second. This is the right one. Are you getting the thing? Are you getting the thing? Are you getting the thing? Are you getting the answer? Are you getting the concept? Is that concept is clear? Is that concept is clear? Shall we move to the next question? Yes. Shall we move to the next question? Yes, tell me. Yeah. Shall we move to the next question? Is that concept is clear now? Is that concept is clear now? This that concept is crystal clear now. Most of them have given the right answer. It means what? Some of them say, sir, 5.93 mm per second. Some of them say 118.8 mm per second. Some of them say, sir, 16.9 mm per second. My dear, this one is the wrong answer. This one is the wrong answer. This one is the right one. So, very good. Okay, shall we move to the next question? Yes, shall we move to the next question? Okay. Now, let's move to the next question. Again, it's a new question for you people. Solve. Solve. Okay, solve please. Solve. Yes, please solve the question. Please solve the question. An oxyacetylene torch supplies 0.3 meter cube of acetylene per hour. Please note down the data. Data are very important. Right? Data are very important. Inoxidine torch supply of how much? 0.3 mm acetylene per hour. This is the rate of supplying the acetylene. This is rate of supplying the acetylene. An equal volume rate of oxygen for an oxyacetylene welding. Equal volume, it means neutral flame we are using. Okay. On what? On 4.5 mm thick sheet. A sheet which is going to be welded, whose thickness is what? 4.5. Whose thickness is what? 4.5. Okay, 4.5. Let me make it little bit more darker. Yes, 4.5 mm thick. Heat generated by the combustion is what? That heat is going to be generated. How much? 5.5 10 to the power 6 joule per meter cube. Transfer to the work surface with a heat transfer factor. My dear, heat transfer factor is what? 0.2. If 75% of the heat from the flame is concentrated, 75% of the heat from the flame is concentrated in a circular area on the work surface, that is what? That is 9 mm in diameter. Okay, that is 9 mm diameter. This is the important data. I think you have noted down. You have to find A, rate of heat liberated during combustion. You have to find A, rate of heat liberated during combustion. You have to find B, rate of heat transferred to the work surface. You have to find C, average power density in the circular area. That is in watt per mm square. That is in watt per mm square. That is in watt per mm square. I hope you like these questions. All are these questions from the standard books. Okay, which are unsolved question. Which are what? Which are unsolved question. I hope you like this question. Right? I hope you are like this question. So again I am repeating the data. In oxyacetylene torch, how much? 0.3 meter cube acetylene per hour is supplied. My dear, equal volume rate of oxygen is coming. Equal volume means it is a neutral flame welding on the thickness of sheet, that is 4.5 mm thick sheet. This is the thickness. Heat generated by the combustion that is 55 into 10 to the power 6 joule per meter cube. Okay, meter cube. Shahrukh Siddiqui says, sir, 4583.33. Yes, the first, I think it's the answer of first now. First one is right. Okay, so transfer to the work surface, how much? A heat transfer factor is 0.2. If the 75% of the heat from the flame is concentrated in a circular area on the work surface, that is what, 9 mm in diameter, find these three things. Shall I solve? Okay, 919 point. Beta, Karthik, this is wrong one. Your first answer is wrong. Shahrukh Siddiqui has given the right answer. Shahrukh Siddiqui, congratulations. Congratulations. You have done this question. Congratulations. Okay. Look, shall I solve this question? All of you have noted down the data? All of you have noted down the data? All of you have noted down the data? Okay. I am going to solve this question. Right. I am going to solve this question. Okay. Let's solve this question. Let's solve this question. Okay. Now, let's solve this question. It is given that acetylene torch supply how much? Shall I, I'm going to write each and everything. Acetylene gas, my dear, acetylene torch, the acetylene, okay, the acetylene, which is coming, how much? 0.3 meter cube per hour, right, per hour. But the heat is produces, again it is given that the heat which is produces, okay, the heat which is produces, the heat, how much? The heat which is produces is, I think 55 into 10 to the power, okay, 55 heat per volume. It is a what? Heat per volume. 10 to the power 6 joule per meter cube. Now the total heat is what? Now the total heat is what? Basically 55 into 10 to the power 6 into 0.3. Is that the right one? Am I doing the right thing? Am I doing the right thing? Yes or no? So 0.3 into 55 10 to the power 6. My dear, first of all, it is important that you should write the unit, because if you write the unit now, then your solution become very easy. Now, my dear, it is 55 into 10 to the power 6 joule per meter cube into 0.3 meter cube per hour, right, per hour. Now we have to find the answer in joule per second. So 55 into 10 to the power 6 into 0.3, okay, 0.3, answer divided by hour, that will be answer divided by, okay, answer divided by 55, okay, yes, 0.3 into 55 into 10 to the power 6, okay, answer divided by 60, answer divided by 60, yes, 4583.33 joule per second. So this is the right one. This is the right one for A. For A, this is the answer. Now for B, what is asking for the B? Rate of heat transfer to the work surface. To the work surface. My dear, it is given that transfer to the work surface with heat transfer factor of what? 0.2. Heat transfer factor of what? 0.2. So you have to multiply the above answer for above answer. You have to multiply for B. For B, the heat will be what? The heat which is transferred to the workpiece is transfer factor, that is 0.2, 4583.33 joule per second, right? Joule per second. So answer into 0.2, it comes 916.66 joule per second, right? Now the next part, that is option, that is part C. That is part C. Average power density in the circular area. Average power density in the circular area. Yeah, tell me. average power density, average power density in the circular area, average power density in the circular area. What he says, basically that flame is concentrated in a circular area. A flame is coming now, a flame is coming from the circular area, a flame is coming from the circular area. So how much power, okay, is concentrated in the circular area from that flame, okay, from that nozzle, that flame is coming, and the cross sectional area or the diameter of the nozzle is given concentrated on circular area on the work surface, that is 0.9 mm in diameter. Yes, tell me. The C answer is 10.81. Yes, the right one is 10.81. Now the power density is what? Very simple now. The power density is what? You have to find the power density. Power density. Power density. So the unit of power density in which unit? That is in watt per mm square. Right, watt per mm square. The thing is, basic, the heat, how much, and area is pi by 4 9 square. Now again the question is, sir, how much heat we are using? My dear, it is given that if 75% of the heat from the flame is concentrated, what is given? Heat from the flame is concentrated in circular area. 75% heat is concentrated in a circular area on the work surface, that is 9 mm in diameter. So 75%, the heat which is coming from the nozzle, okay, 75% of that heat, you have to use 75% of that heat, and the heat which is coming is what? The heat which is coming from the workpiece, is what? 916. My dear, it is 916.66, and the percentage is 75%, means 0.75. Is that clear? And divided by what? Pi by 4 d square, that is what? 9 square. Tell me yes or no. Is that clear? The concept is clear. Yes or no? Tell me. The concept is clear. So it is coming 10.806 watt per mm square. Is that clear? Anybody has any doubt? Is that clear? Anybody has any doubt? Yes, my dear student, is that clear? Anybody has any doubt? Shall we move? Okay, let's move to the next question. Again, the next question is a very good question. Try and solve it. Right? Try and solve it. Please note down the each and every data. Two aluminum alloy plates, each 10 mm thick, okay, and 1 meter long are welded without any crowning by multipass, tungsten inert gas butt welding. The joint configuration is V type with 60-degree angle. The joint configuration is what? V type, and the angle is what? 60-degree angle, and the root gap is what? Here the root gap is what? 5 mm. My dear, 5 mm is a root gap. And length is what? 5 mm. And length is what? 5 mm. If the electrode of 5 mm diameter, and 500 mm length is used for welding, then the number of electrode required is, then the number of electrode required is. Please note down the data so that I can solve the question. Please note down the data so that I can solve the question. Have you noted? Two aluminum alloy plates, each 10 mm thick, 1 mm long, are welded without crowning by multi-pass tungsten inert gas butt welding. The joint configuration is V-type with 60-degree angle and the root gap is 5 mm and the length is what? 5 mm. No beta? Wrong. I think you mug up the previous question. Little bit changes is there, my dear. Little bit changes is there. All of you have given the wrong answer. Sorry. This is not a PYQ question first of all. Okay, you learned the PYQ question, that's why you are giving direct answer. This is not a PYQ. Not a PYQ. Me and my team has changes this question. Okay, we have done a changes. A beautiful changes is there. So please listen it carefully, yaar. Please listen it carefully at least. Wrong one. Kiran, you have given the wrong answer. Even also Rishabh, you have given the wrong answer. Sir, question नहीं बन रहा तो confidence low हो रहा. Sir, question नहीं. बेटा question you are not solving the, you are not able to solve the question because maybe that you haven't completed. Maybe that you haven't completed your theory. The second thing is that all questions are new. All questions are not on the basis of PYQ, right? If I gave you the PYQ, then there is no meaning, because on each and every platform everyone is solving PYQ, and on this platform, only on this our platform, we are solving what? New question. So that's why maybe you are not able to solve. Two things are there: that you haven't completed your theory, you are not strong enough in your concept. Second, all the questions are new, so you have to apply your mind. What is land? Again, root gap and land. Have you forgotten? Molly Gunturu, what is land? Yeah, please remember, please recall. What is land? What is land? Forgotten? There won't be a two thing now. Root gap and land. Root gap and land. Sir, your teaching is very good. Sorry, sir. Could not write at that time. Okay, thank you. Yes, sir. Revision कैसे करें? I forgot most of the thing. Okay, my dear, for production, we have launched the crash course now from morning 8 to in the evening 11. From 8 to I think 10 or 11 a.m. From 8 to 10 a.m. From 8 a.m. to 10 a.m. industrial is going on, right? From 8 a.m. to 10 a.m. industrial is going on. Then for crash course, this is Abhyas batch. Then Negi sir is also taking a thermodynamics, right, in a crash course, right? Then in the evening from I think 9 to 11, so they saying sir is taking production. So if you forget the each and everything, at least attend those crash course so that you can revise the thing. Okay, now I am going to solve. Shall I solve this question? Because nobody has given the right answer. Shall I solve this question? Okay, I am going to solve this question. Otherwise, what happened? You people become demotivated. Now, let me solve this question. Look, you are doing a welding, right? You are doing a welding. Okay, you are doing a welding. See here, you are doing a welding. Please see carefully. See, Now, see, this is a V type, right? This is a V type, and this is a land. My dear Molly Gunturu, are you able to see? This is the land. This is what? This is the land, Molly. This is a land. Are you getting my thing? This is a land, and the thickness of this, the thickness is what? How much? The thickness is again, see here. Here the thickness is what? 10 mm. 10 mm. 10 mm, right? And this is a land, my dear. And land has what? 5 mm in height. 5 mm in height, right? Now, see here. See the thing. Now this weld, right? See. This one. See. This one. So here, this angle is what? I mean the total angle is what? 60 degree? No, 6 is not the right answer. The total angle is what? 60 degree. Now, here, please see. Here, please see. Please see. Okay. Here, please see. Now, first of all, find the total. This is the total height now. This is the total height now, 10 mm. Okay, this is the total height now, 10 mm. So this height is what? This height is what? Tell me that this height is 5 mm. If I am not wrong. If I am not wrong, this height is what? 5 mm. Okay. Now there are find out the total volume. Find out the total. Yes, Rishabh, you have given the right answer. 7 is the right answer. Very good. Very good. So this is what? This is 5, 10, 30. It is a similar triangle. 5, 10, 30. Right. Again, this is the 30 degree. So the total cross section area is what? The total cross section area is, that is A, and this area. So half area of that triangle, half. Base is what? 5, 10 of 30 degree. Now there are two triangles now. Make it twice. Make it twice. Make it twice. Plus, there is a rectangle of root gap of how much? Of root gap of 5 mm. This is a root gap of 5 mm. So 5 into what? 5 into 10. So this is the total area. Are you getting a thing? This is the total area. Okay, this is the total area. My dear, you can find out the total volume also. You can find out the total volume. If I am going to find out the total volume, then what I have to do? I have to multiply into what? I have to multiply into the length. And the length is what? You know the length. The length is what? This is the length now. This is the length now. Okay, this is the length. Right, this is the length. And that length is what? And that length is basically is what? 100 mm. Right. So the volume of the total volume of the welded bead is what? That is 2 to cancel. So 5 into 10 of 30. Okay, plus 50. Okay, answer into 1110. So volume is coming. Okay, so here the volume is coming. So what will be the answer? Here the total volume is what? Total volume is, let me calculate, is 5 into 10 of 30 degree. Okay, so answer plus 5 into 10. Okay, so answer into 1000. Okay, so a total volume will become now, right? So the total volume will become now. I think each and everything is right. 5 into 10, twice of 1 by 2. Yeah. Now, volume of electrode. Volume of electrode. Volume of electrode is what? Pi by 4 d square into L. So pi by 4. Pi by 4 d is what, my dear? Diameter is what? Diameter 5 mm in diameter and 500 mm long, right? So 5 square into 500 mm in length. How much? 500 mm. 500 mm in length. So here 500 mm in length. Okay. Total volume. Total volume of electrode. Total volume of electrode. Let's say n number of electrodes. If you multiply pi by 4 into 5 square into what? 500. Now correlate that number. Correlate that equation. If you are going to correlate this equation, then you will get n approximated is what? 7. n triangle area में बस base नहीं लिए हो सर, half base. Okay, half base. Yes. This is half. Sorry. This is twice. This is half. Base is what? 5, 10, 30 into altitude, that is 5. Now it is completed, right? It is completed. Now it is completed. So 2 and 2 cancel. So it is the 5 into, let me calculate, 5 into 10 of 30 into 5, answer plus 50, answer into 1000. So it is coming 644. Okay, 644 30. Okay, half base into altitude. Is that right? So if you compare this, then your n will become what? N will become 7. Now let's move to the next question. Yes. No beta, 11 is not a right one, Molly. 11 is not a right one, 21 is not a right. 7 is coming now. And this is the concept now. I have explained now, very simple concept. Yaar. Very simple. Just see. This is what? This is a triangle, half. Okay. This is a triangle. Okay. And this is what? This is the height of the triangle. Right. This is the height of the triangle. So the triangle is what? So here the triangle is what? The area of this triangle is what? Area is what? Half base. That is 5 of what? 10, 30 into what? Altitude. Half base into altitude. Altitude is what? 5. So this is the area of one triangle. So the total triangle is what? There are 2 triangles. Multiply by 2. Now this is what? This is a rectangle. Rectangle whose root gap is 5 and length is what? 10. So plus 5 into 10. This is a total cross-sectional area. Multiply the length of the workpiece. You will get the total volume. If you equate this to the number of electrode volumes, then you will get n equal to what? 7. Right, Polly? Okay. Now let's move to the next question. Now let's move to the next question. Yes. A riser in casting is described by which of the following? How can you describe a riser? A. An insert in the casting that inhibits buoyancy of the core. I think no. So is not the right one. Riser is a gating system in which the sprue Sprue feed is directly into the cavity. Sprue feed is directly into the cavity. Is that? No. Riser, metal that is not part of the casting. It is not part of the casting. Yes. Source of the molten metal to feed the casting and compensate for shrinkage during solidification. Yes. And waste metal that is usually recycled. Yes. So I think C, D and E is the right one. C, D, E. Yes, Karan Bhadoria. Bhavesh Tiwari, D, not only D, C, D and E. Three statements are right corresponding to the riser by. Three statements are right corresponding to the riser, yaar. Three statements are right. Am I clear? Three statements are right. Now, let's move to the next question. Question number 6. Question number 6. Here you will need a one equation. I will explain that question. A vertical to centrifugal casting. In the previous years, the solidification is compensated by shrinkage allowance. Yeah, liquid shrinkage, na? Liquid shrinkage is compensated. After casting, you are going to Suraj Pandit. After casting, you are going to cut, na? You are going to cut the sprue, na? So final sprue is not a part of the final casting now. Tell me, Suraj. Suraj, sprue is not sprue, or you can say riser. Sprue or riser. Sprue or riser are not the final part. Okay, let me see the next previous one. What do you say? Source of molten metal to feed the casting and compensate for shrinkage during solidification. My dear, what say? During solidification. Solidification is what? Solidification is what? Solidification means basically you are giving from what? You are giving from liquid to solid. Liquid to solid. Beta, whenever you go from liquid to solid, then first of all what happened, my dear? Liquid shrinkage na. Liquid shrinkage will be happen. Liquid shrinkage will be happen na. That liquid shrinkage is compensated by what? By riser. Have you forgotten? That liquid, let me show you the graph. If you have forgotten, let me show you the graph. If you have forgotten, no problem, I will explain it. I will explain it. No problem. No problem. See, suppose that this is the pouring temperature. Please see. Please see. Suppose that, Pallav, suppose that this is the pouring temperature. At that point, you are pouring the liquid metal. Now, here the liquid metal will reach. Here the metal is in liquid state. Here the metal is in what? Is in the liquid state. Right. When the metal temperature, when the liquid metal temperature is cooled down, then there will be a shrinkage. So, riser. This is what, Pallav? This is what, Pallav? This is the riser. This is the riser. So, riser will supply the liquid metal. Right. Now, from liquid to solid, again there will be a shrinkage. So, here also riser will provide the liquid metal. But once it converted to solid, Pallav, then what happened? It will drop down from solid that is at a high temperature, solid that is at what? Low temperature. Then that compensation, that shrinkage compensation is compensated by allowance. A pattern allowance. It is compensated by pattern allowance. Am I clear, Saurav? Am I clear to Pallav Kumar? Okay. So this is the, basically on the basis of that, I have selected which option? I have selected option D. Okay, D. Right. So let's move to the next question. Question number 6. Let's move to the next question. Question number 6. Question number 6. Yes, please. Solve the question number 6. Solve the question number 6. Solve the question number 6, please. Solve the question number 6. Solve the question number 6. Solve the question number 6, please. In the previous year gate, a centrifugal, a question which is based on the centrifugal, but the axis of rotation is what? Horizontal. But here we ask you a question on the basis of two centrifugal whose axis of rotation is what? Vertical. Whose axis of rotation is what? Vertical, right? Whose axis of rotation is what? Vertical. So a vertical two centrifugal casting process is used to produce bushings that are 200 mm long and 200 mm in outside diameter. 200 mm outside diameter. Okay, 200 mm outside diameter. Basically there is a bush. Okay, basically there is a bush. Let me see some diagram. Some 3D diagram is available or not. Okay, see here. Right. So this is the bush we are going to produce. This is a bush we are going to produce. Right. This is a bush we are going to produce. And here this is the outside diameter. Here this is the outside diameter and this is the inside diameter. Outside diameter and inside diameter. Outside and inside. This is the bush basically. Here internally, when you go from top to bottom, the diameter is going to reduces. When you go from top to bottom, the diameter is going to what? Reduces. The diameter is going to what? Reduces. Right? The diameter is going to what? Reduces. Top to bottom. The diameter is going to what? Reduces. Right? So, the internal diameter. Just a minute. I am trying to draw the figure in a very clear manner so that you can understand. See, this is the top internal diameter. A vertical centrifugal casting process is used to produce a bushing that are 200 mm long and 200 mm outside diameter. My dear, here this diameter is what? This diameter is what? If I draw this diameter, this diameter is what? 200 mm. 200 mm. And the length is what? And here the length is what? This is the length. This is the length of what? 200 mm. This is the length of what? 200 mm. Right. Now 200 mm outside diameter. If the rotating speed during the solidification is, here the RPM is given. Here the RPM is given, that is 500 revolution per minute. Determine the inside diameter at the top. Determine the inside diameter of the top. This is the inside diameter of the inside radius of the top. Right. This is the inside radius of the top, and this is what? This is the see, this one. I am talking about this one. This is the inside diameter at the bottom. Okay. Determine the inside diameter at the top of the bushing, that is RT. If the inside diameter at the bottom is what? Inside diameter, that is what? That is inside, that is your radius of the bottom. That radius of the bottom or diameter is given, that is 150 mm, which implies that radius of the bottom, inside diameter of the bottom is what? That is 75 mm. Am I clear? 75 mm. Okay. Now you have to find that RT. My dear, there is one relation which is used in this question. What is that relation? Here RPM equal to 30 by pi. RPM equal to 30 by pi root of 2GL divide by RT square minus RB square. Where L is what? Where L is the length. My dear, in this formula, here you have to use that equation. Here N is the RPM, 30 by pi, root of 2G. G is a gravity constant. L is what? Length of the bush. Divide by RT. RT is what? The inside top radius. The inside top radius. Right? The inside top radius. Minus RB square. Okay. So here the RPM is what? 500 revolution per minute. 30 by pi root of 2 into G, that is 9.81 into L, that is what? 200 divided by RT square, which you have to find out, minus RB is given, that is what? 75 square, which is given. Okay, 75 square. Okay, now if you solve, but here one thing, here G is what? G is in meter per second. Just a minute, G is what? G is in meter per second. So in meter per second, you have to write 0.075 meter. And also here I did one more mistake. It is 200 mm. So I have to write 0.2, right? 0.2. The length is 0.2 meter. Okay, and RB is 0.075 square. Am I clear? So solve this. You will get your RT. Solve this. You will get your RT. So RT will become 83.99 mm, and just multiply twice. 83.99, just multiply by twice, it comes 167.98 mm. Is that clear, my dear? ये फॉर्मूला याद रखना पड़ेगा या कोई और तरीका हो सकता है? सूरज पंडित, there is a one thing that in the exam what there will be in the exam, one thing is there. In the exam one thing is there. What is the thing? The thing is that examiner will provide you the relation. Either examiner will provide you the relation, otherwise learn it. Okay, otherwise learn it. Now solve the next question. Yes, please. Question number 7 of this session. Suraj Pandit, sometime examiner will give you the relation, but it's my recommendation that you should learn this formula for bushes, right? For bushes. Yes. Solve the question. Again, a new question. A riser in the shape of a sphere. There is a riser which is in the shape of a sphere, is to be designed for a sand casting mold. The casting is rectangular plate with a length 200 mm, width 100 mm, and thickness 18 mm. If the total solidification time of the casting itself is known to be 3.5. Very difficult questions. Thank you, yaar. It means my and my team work has successful. Satish Kumar, thank you very much. You say, sir, very difficult question. It means my and my team work is successful, because our motive is to provide you a next level question. Our motive is to provide you the next level question. a very good level of question, right? Not a PYQ. By mistake, sometime we solve the PYQ, but our intention is to provide you a next level question, a difficult question, because on each and everywhere, PYQ are people are solving PYQ. No one else is solving a difficult problem, a new problem, okay, from the standard book. So me and my team are developing a new questions, a difficult questions for this session or for the upcoming session. Thank you for your compliment that the questions are difficult. Thank you, Satish Kumar. A person he says that 12.54, what is that 12.54? Determine the diameter. Okay, diameter is 12.54, but I think this question is very easy, pretty easy. Diameter, find out the diameter. Okay, note down the data. Okay, note down the data. Do one thing, note down the data. First of all, what are the data? Sphere riser designed for a sand casting, rectangular. Length of width is what? 200. Width is what? 100. Width is what? 100. And width is what? 100. And thickness is what? 18 mm. If the total solidification time of casting itself is 3.5, determine the diameter of the riser. Okay, so that it will take 25%. It will take 25% longer than the riser solidification time. Okay, now solve this question. Basically, there is a spherical riser. This is a spherical riser. Okay, and below that spherical riser, this is the casting. Okay, and the casting has, the dimension, right? The dimension of the casting. This is the dimension of the casting. Okay, this is the dimension of the casting. This is the dimension of the casting. This is the dimension of the casting, right? This is the workpiece. Now, here, dear student, this is a sphere, right? This is a sphere. Now, so solidification time of casting. Solidification time of casting is what? B into volume divided by surface area of what? Of casting square, right? Of casting square, right? Of casting square, right? So first of all, find out the volume of casting. My dear, volume of casting is what? It is given that length is what? Length is 200 mm. Length is what? Length is 200 mm. Okay, it is 200 mm, right? 200 mm. And the width is 100 mm. The width is what? The width is what? 100 mm, right? And the height is what? The thickness is 18 mm. The thickness is 18 mm. 18 mm. So 200 into 100 into 18 mm cube. So this will be the volume. So what will be the total volume? If you calculate this, it will come 200 into 100 into 18. It will become 36. It will become 360000. 1 2 3 4 36, right? Mm cube. Mm cube. Now the surface area of the casting. Surface area of the casting is what? Twice of 200 into 100 plus 100 into 18 plus 18 into 200. This will be the surface area of the casting. So surface area for casting, you will calculate the surface area. It will become 50800 mm square, right? It will become 50800 square. So total solidification of casting here B. Okay, volume is what? Volume is 36 divided by 3.50800 square. Now, solidification time of riser. He says that solidification time of riser is what? 25% higher. He says that solidification time of riser. He says solidification time of riser is 25% longer than for the riser. Okay. Okay. So solidification time of casting 1 plus 0.25. So solidification time of riser is what? That is TC 3.5 1.25. This is a solidification time of what, my dear? Riser, right? Now, what you do? Do one thing. What you do? Do one thing. Now do the calculation properly. Now, you know that solidification time of riser, B, volume of the riser divided by surface area of the riser square. Now, solidification time of riser, B. Here, B in both the case are what? Same, because molding is what? Molding sand is same. So the volume of the riser, that is what? Volume is what? 4 by 3 pi r cube, if r is the radius of the sphere, divided by 4 pi r square of the riser, okay, square. So 4 pi r square, this cancel. So r by 3 square. Now, my dear student, okay, you can find out the thing. Is there any now tell me, is there any difficulty? Is there any difficulty? Is there any difficulty? Can you find out the thing? Yes or no? TR is what? TR is basically solidification time of riser is what? Okay, I forgot to write down B. Solidification time of riser is what? B into R by 3. Now do one thing. TR divided by TC. So TR is what? B into R by 3 square divided by this B into 3600500800. Am I clear? Am I clear? It is what? It is the square. Now you know the value of TR. TR is what? You know the value of TR. Now TR is what? TR is 3.5 into 1.25. And you know the TC. TC is what? That is what? 3.5. Can you get the value of R? Can you get the value of R for me? Can you get the value of R from me? Yes, please. Can you get the value of R from me? Can you get the value of R from me? So it comes, my dear, 23.765 mm. But you need the diameter. Diameter is what? Answer into twice, that is 47.53 mm. So, is that clear? Is that clear? Is that clear? Yes, tell me. Is that clear? Arey Baba, tell me. Is that clear or not? Is that clear or not? Is that clear or not? Is that clear? Is that clear? So, shall we move? Shall we move? Okay. Now let's move. Let's move to the next question. Now again, this is the next question. Solve please. Again, this is the next question. Solve please. Again, this is the next question. Solve please. In casting experiment performed using a certain alloy and type of cell mold, it took 155 seconds for cube shaped casting to solidify. It's a very easy question. Believe me, this question is very easy. Okay. Believe me, this question is very easy. You can solve this question. Believe me, this question is what? This question was easy. This question is easy basically. Yes. Yes. So in a casting experiment performed using a certain alloy and type of sand mold, it took how much? It took 155 seconds for a cube shaped casting to solidify. The cube was 50 mm on a side. There is a cube whose side is what? 50 mm. Okay. Casting experiment performed using a certain alloy and type of sand molding. It took 155 seconds for a cube shaped casting solidify. The cube is 50 mm on one side. Determine the value of the mold constant, that is in second per mm square according to Kronovic rule. You have to find the very easy question. Very easy question to motivate you. This question will motivate you, right? This question is very easy. This question is what? Very easy. So please solve. This question is very easy. Shall I solve this question? Okay, I'm going to solve this question. It's a very easy question. Now A, you know that solidification time equal to B volume divided by what? Surface area. Okay, square. So 155 second is given. T is what? T is 155. B volume of cube, that is what? 50 cube, right? Divided by 6 time of 50 square. 6 time of what? 50 square whole square. 50 square, this cancel. So it will becomes out 155 equal to B 50 divide by 6 square. So you will get the value of what? You will get the value of B. So what is the value of B? What is the value of B? B is 2.232. B is what? 2.232. 2.232 in second per mm square. Second per mm square. Okay. Now we will get the value of A. If the same alloy and mold type were used, same alloy and mold type is used, find the total solidification time for a cylindrical casting in which the diameter is what? 30 and length is what? 50. Find the total solidification time, right? So here you know the value of B. Find out the volume of the cylinder. Volume of the cylinder, that is what? Pi by 4 d square into L. So pi by 4. So here pi by 4 d square, diameter is what? 30. Diameter is what? 30 into 30 square into 50, right? So the volume of the cylinder is what? That is shift pi by 4 into 30 square into 50. That is volume is coming 35342.917 mm cube. Now the surface area is what? Surface area is twice of pi by 4 d square plus pi dl. This is what? This is the surface area, right? This is what? This is the surface area of the cylinder. So the surface area will be come out. I am going to write down directly 2 into shift pi by 4, okay, into d square. D is what? 30 square, okay. Answer plus shift pi into d30. L is what? L is 50. It is coming 61. Surface area of the cylinder is coming 6126.105 mm square, right? Mm square. Now solidification time is B. B is what? B is 2.22. Okay. Volume is what? Here the volume is 3534. Okay. It's a 3534.4. Just a minute. I have did some mistake. 42.9, sorry, it's a 42.9 divide by 6126.105 square. So solidification time will become in second, in minute. Find out in minute. In minute it is 1.238 minute. Very good. Okay. Shall we move to the next question? Okay, I am going to move to the next question. Yes. Just leave that question. Okay, solve this one. Or would you try to solve this one? Try this. Try this. Try this. Try this question. It's based on PYQ, but it is not exactly the same. The question is based on a PYQ, but it's not exactly the same one. If you are looking for that question, here we did little bit changes. Here we have done little bit changes, so that you have to put your little bit effort. Right? So I'm agree that the question is totally based on your PY. That question only. I mean, the previous questions are totally new. This question number 9, is based on your PYQ, but little bit changes is there. So you have to put little bit of your effort. Yes. Tell me. Sir, explain production technology. I am civil, please. सर, मुझे इंजीनियरिंग में मैकेनिकल लेना है, अभी डिप्लोमा हूँ सिविल से. बेटा ये बैच आपको पता है ना सार्थक, अभ्यास बैच है. अभ्यास बैच पे हम सिर्फ और सिर्फ आपका क्वेश्चन डिस्कस कर रहे हैं. अगर आपको प्रोडक्शन टेक्नोलॉजी समझना है तो आपको यहाँ पर या तो क्रैश कोर्स ज्वाइन करो यूट्यूब के ऊपर, ठीक है. अदरवाइज पेड बैच तो है ही है. अभी फ्री में जो अपने को मिल सकता है वो क्रैश कोर्स है, वहां आप उसका मजा लीजिए. समझ में आए तो अपन देखेंगे फिर कि हमको आगे पेड बैच पे किस तरीके से काम करना चाहिए कि हमारा डिप्लोमा से है आप तो आपको दिक्कत ना आए. ठीक है ना. यस प्लीज. यस, टेल मी. सर तक क्या है ना कि आई डोंट रिकमेंड, आई मीन इट्स अ जेन्युइन सजेशन, फ्री ऑफ कॉस्ट यू आर गेटिंग द थिंग ऑन यूट्यूब राइट नाउ, सो यू कैन एनालाइज योर सेल्फ. राइट, आप एनालाइज कर सकते हो. सुदेश सिंह सर अभी प्रोडक्शन टेक्नोलॉजी ले रहे हैं, है ना. 5-6 क्लासेस सार्थक उनकी हो चुकी है. सुदेश सिंह सर की रात को 9 से 11 रहता है उनका, तो वो सेशन अटेंड करो, तो उससे आपको पता लग जाएगा. 63 किलो न्यूटन मीटर. somebody says that, what I'm asking beta I'm asking the torque is assumed to act at the Suraj Pandit, I'm not asking about the torque. First of all, Suraj Pandit, I'm not asking about the torque. I'm asking where the torque is acting. First of all, your torque value is totally wrong. And secondly, you haven't understand the question yet. I'm asking where the torque is acting. Okay, where the torque is acting. Which part of the radius? Okay, torque is acting. On which part of the radius torque is acting? I'm asking that question only. My dear. I'm asking that question only. Okay na? Summary, Internet of Thing branch eligible. Internet of, yes. Yes. Anybody? Or shall I am going to solve this question? सर कास्टिंग और वेल्डिंग के क्वेश्चन एक साथ करोगे क्या? हाँ बेटा, वेल्डिंग के कर चुके हैं ना सर. योर टीचिंग लेवल, yes. So it doesn't matter that how many students I am teaching. The only thing is that how much students are dedicated. Tarun Purohit, it is not matter that to how many student I am teaching. Tarun Purohit, it is not matter that to how many student I am teaching. The only thing is matter that how many students are dedicated. Tarun Purohit, it's for you. It's only matter that how many students are dedicated. Like you are also dedicated. That's why you are here. You are also very dedicated. That's why you are here. I am also very dedicated. That's why I am teaching. Very simple. Very simple. No. Molly Gunturu. Wrong. 8 mm is not the right one. Molly Gunturu. 8 mm is not the right one. Molly Gunturu. 8 mm is not the right one. No. 8.02 is not the right one. Sorry. 8 is not the right one. 8 mm is not the right one. 8.02 is not the right one. 8, just let me check. Beta, I am asking the fraction. Please see. Please see. The torque is acting to act at the that by that of the radius. Of the radius of the rotating bar. It means you have to tell me the fraction. You have to tell me the fraction, Sir Brian. You have to tell me the fraction. I mean, how much fraction of the radius? How much fraction of the radius the torque is acting? How much fraction of the radius the torque is acting? Right? How much section of the radius? I'm not asking about the value of radius. I'm asking about the fraction of the radius. I'm asking about the fraction of the radius. I'm asking about the fraction of the radius. Are you getting my thing? Fraction 0.8. Yes. Now I am getting the right. Very good. 0.8. Okay, 0.8. And the fraction is what? Fraction is 4 by 5. 4 by 5. 0.8 or you can say 4 by 5. Very good. 0. Very good. So here answer is 0.8. Okay, of the radius. 0.8 of the radius. Very good. Molly Gunturu, very good. 0.8. Yes. Now I am going to solve this question. Here power is given now. Power is what? Power is 197.8 kilowatt. So 197.8. So 800 watt. You know the power, that is what? 2 pi n. Okay, what is power? 2 pi n into torque divided by what? Because here n will be in revolution per minute. I am going to divide 60. Here RPM is given, that is what? 6,000. So 197,800 equal to 2 pi, okay, into n, that is 6,000 into t, divide by what? Divide by 60. So the T will be, here the torque will be 197,800 into 60. Answer divide by, 197,800 into 60. Answer divide by, okay, 2 into shift pi into 6,000. It is coming, torque is coming 314.808 Newton meter. That much torque is coming, right? That much torque is coming. You know the torque is equal to what? Torque is equal to basically friction into, let's say what? Let's say n times of the radius. N times of the radius. N times of the radius, right? So what is the value of friction? Here you can find the value of friction. Basically you can find the value of friction. You find the value of force which is acting on the bar, and the force is what? Pi by 4 d square into 250 into 250. That much Newton will become. So shift pi by 4 into d square, that is 20. Okay, that is 20 square into 250. It is coming, force is coming, okay, 78539.81 Newton. Now what will be the friction? Friction will be into mu into capital F. Mu is what? Mu is given. Mu is 0.5. So 0.5 of the force. Answer into 0.5. It is coming 39269.908. Okay, that much Newton. Now the torque is what? 314.8. Friction is 39269.9. N times of what? Radius. N times of what? Radius. So 314.8 divided by answer. Okay, divided by, okay, here N divided by basically 314.8 divided by 39269.9. Okay, R is what? R is 10 to the power 10 into 10 to the power minus 3. So it will become 0.8. So 0.8 means or you can say 4 by 5. You can say sir, it will be, you can say sir, it will be what? It will be 4 by 4/5 of the radius of the bar. 4/5 of the radius of the bar. 4/5 of the radius of the bar. Is that clear? Is that clear? Now let's move to the next question. Let's move to the next question. Yes. Solve. Solve please. Solve. Solve. Yes. What is given that? Three mm thick steel sheet keep at a room temperature of 38 degree Celsius is cut by a fiber laser beam. The laser spot diameter on the top surface of the sheet, that is 0.2 mm. The laser absorptivity of the sheet is 50%. The property of iron are density is given, right? 7800. Specific heat is given, that is 450 joule per kg degree Celsius. Melting temperature is given, that is 1538 degree Celsius, and the latent heat of fusion is given 247 kilojoule per kg. Assume that the melting efficiency is 100% and that the curve width is equal to the laser spot diameter. The maximum speed at which the sheet can be fully cut at 2 kilowatt. What will be the maximum speed? What will be the maximum speed in meter per second? What will be the maximum speed in meter per second? Okay, first of all, here the given power is what? Here the given power, right? Here the given power is given 2 kilowatt, but only 50% absorptivity will there. 50% of the absorptivity will there. So 2 basically here 2000 into 0.5, so only 1000 watt. Okay, only 1000 watt is going to be what? Utilized. 1000 watt is going to be what? Utilized. Now there is 100% conversion, means you are providing 1000 watt. That 1000 watt is utilizing completely to melt the workpiece. Okay, let's say that is the mass melting per unit time. That is a mass melting per unit time into specific heat into change in temperature plus latent heat, right? Plus latent heat. Now if you do that thing, you will get the mass. Yes, tell me yes or no. You will get the mass. Now how much mass is melting per unit time? how much mass is melting per unit time. My dear, it is given a 3 mm thick sheet, okay, is going to cut by a laser, okay. On the top surface, the diameter which is cutting now, the diameter is what? 0.2. It means that on that surface, suppose that this is a sheet, right? This is a sheet. By using the laser, this is a sheet of thickness of what? 3 mm, and by using the laser, that much cross section, that much circular perimeter, you are cutting. If you multiply that circular perimeter, into height, that is into thickness, then you will get what? Area of the cross section area which you are going to cut, and the area is what? That is 3 mm into 0.2. So 3 into 0.2, that much mm square. So area is what? 0.6 mm square. That much cross section area is going to be cut. Now let's say V is the velocity. So the volume which is going to be melt of the workpiece is what? That is AC into what? V is the welding speed in mm. Here V is the laser speed. Here V is what? Laser speed in mm per. Here V is the laser speed in mm per second. V is the laser speed in mm per second. So here volume is what? 0.6 V, right? 0.6 V mm cube per second. Now you know the density. So the mass which is melting, which is cutting per second is what? That is volume, okay. That is what? Volume melting per unit time into what? Into density. So here the volume, my dear, you have to convert, you have to write the volume. Volume is in mm cube per second. So 0.6, my dear, 0.6 divided by 0.6 into V, and density is what? Here density is 7800. My dear, either you should convert in what? Either you should convert in meter cube. So 0.6 divided by 10 to the power 6 into V, it will become meter cube per second. Am I right? It is an mm cube now, divide by 10 to the power 6. So it will comes in meter cube. It will comes in what? It will comes in meter cube. It will comes in meter cube. Or directly you can convert here also. Right? Directly you can convert here. Leave it. So this is a density. This is what? This is a density. Are you getting this point? 0.232. 0.231. Yes, this is the right one. Kiran Kumar, this is the right one. Right, this is the right one. So the mass which are going to be melt here. 0.6, okay, into V. So my dear, 0.6 into V. So here I am going to convert this 0.6 into V into 7800. I am going to convert in kg per meter cube. So 0.6 divided by here 10 to the power 6 into 10 to the power minus 3, it will become in kg. It will become in kg per second, right? Kg per second. So what will be the value? The value will be 0.6 into 7800. Okay, answer divided by 10 to the power 6 into 10 to the power minus 3, it will become 4.68, right? 4.68 10 to the power 4.68 10 to the power it will become, right? Now it is better that you can use that value here. So you know the heat is what? That is the heat, 100 watt. Put here. Okay, that mass 100. Sorry. So here power is what? 100 equal to m dot is what? 0.6 into V 7800 divided by 10 to the power 6 into 10 to the power minus 3. C, specific heat is given. What is the specific heat? that is 450. Okay, that is what? 450 into change in temperature. Melting temperature is 1538, room temperature is 38, so 1500 degree. So here 1500 degree plus one more thing, the latent heat of fusion 247 kilojoule. So here 247 into 10 to the power 3. If you calculate here, then you will get your welding speed, that is 0.231 mm per second. Yes, is that clear? Is that clear? 1, 2, 3. 3 people has given the right answer. Very good. 3 people has given the right answer. Very good. Okay. My dear, this question I am giving you as a homework. Okay, homework means it will work as for your DPP. Okay, as a DPP, you can solve this question. This I am going to give you 1, 2, 3 and 4. Okay, yes, I am going to give you 4 question, right? I am going to give you 4 question as a homework or DPP. So this is also your, this is also, and this is also, right? So I hope you enjoyed this session, right? I hope you enjoyed this session. So we are going to meet tomorrow with a new topic, that is metrology and advance and your automation. Metrology and automation. Tomorrow we are going to discuss metrology and automation. Okay. So thank you everybody for watching this session. We are going to meet tomorrow. Thank you. Okay, you need the answer. You need the answer. For 11th question. Okay, you need the answer now. Okay, I will give you. Here the H will become 4 mm. Right? Here H will become 4 mm. And for this, then the required welding speed. Required welding speed, let me check the, okay. Required welding speed, I think required welding speed 9 something will become 9 mm per sec, 9 mm per second, I think. Right, 9 mm per second. And for this 2 aluminum type of alloy, then the root gap, I think again 4 will be the right answer. Sir, can we get these notes? Yes, on the app you will get this note. Sir, in the last question, please explain how are you took. Okay, and for this, the radius of the sphere, I think radius of the sphere is, I think 2 mm. I'm not the right, I don't know the exact answer, but this is I think 2 mm. Right? एरिया कैसे लिया लास्ट क्वेश्चन में? एरिया, अच्छा एरिया कैसे लिया? ये रहा एरिया बेटा, यहां पे सी ना, that perimeter is going to cut. Okay, I will explain on the separate one. Look, एरिया कैसे लिया लास्ट क्वेश्चन में देखो, एरिया कैसे लिया लास्ट क्वेश्चन में देखो. आपकी जो लेजर है, राइट, ये जो लेजर है वो वर्कपीस पे इस तरीके से पड़ रही है, इतना डायमीटर क्या कर रही है? कट. ये डायमीटर कट कर रही है, that is a diameter, and that diameter is what? I think that diameter is that diameter is 0.2 mm. That diameter is what? 0.2 mm. Now this laser is cutting that thickness, then this laser is cutting that thickness na beta, yes or no? That thickness. So how much area is going to be melt or remove? Cross section area, that is what? 0.2 into that thickness, that is what? 3 mm. 3 mm. 3 mm. So 0.6 mm square. Now this laser is moving now. This laser is moving now. If this laser is moving, my dear student, then what happened? This much, okay, or this much. How much volume? How much volume, my dear? This much volume up to this length, this much volume up to this length. Okay, this much volume is going to be what? Remove. Am I clear? Am I clear, Suraj Pandit? नहीं भाई, लेजर आपका यहां पड़ रहा है ना, इतने डायमीटर पे, कितने डायमीटर पे पड़ रहा है, ये डायमीटर और कितनी थिकनेस तक कट रहा है, तो ये एरिया कटा. अच्छा, सॉरी, ठीक है. अच्छा, ये नोट्स कहां से मिलेंगे? पीडब्ल्यू ऐप पे जाइए, आप पीडब्ल्यू ऐप पर जाइए, वहां पर आपको इसके नोट्स मिल जाएंगे. राइट? ओके, then thank you for watching this session.